Hello, this is Phil Thomas from New Era Systems. Today I'm setting up to test a few small BUCs. These are the NJT-5037 14 to 14.5 gigahertz KU band BUCs. Very simple, 3 watt output. The manufacturer says typical 3 watt output, which means a little more, a little less, but that's what we should expect. However, if you have an application that needs 3 watts, these are not the BUCs for you. You'd need to go with something bigger, because we always have problems, especially in Florida, with rain fade issues. Heavy rain will knock down a KU band signal and require that we increase the power to keep the signal alive on the satellite. You can see the front and back of an identical BUC. The one on the right, this is where we connect directly to the antenna, probably by twist flex waveguide, although there are other alternatives. This is the input on this other one, coming directly from a modulator or a modem. Because I'm going to be running RF out of this, I need to sync it, and we call this a dummy load strapped to the back. Basically what happens, the RF signal comes out, it's absorbed by the dummy load, but this device, a cross-guide coupler, is a tap into it, and so we can see the amount of power that's coming out of this BUC, and of course we can measure it using this. That power head is attached directly to this Agilent Power Meter. A very nice digital power meter, easy to use and very accurate to see the output from any sort of amplifier. The signal that drives this BUC, this morning I'm using a Comtech 570L L-band modem. The L-band modem has 2 features that we need to operate this BUC. It has a 24 volt DC power supply, but the other equally important point is that this modem produces a 10 megahertz reference. Without a 10 meg reference, the BUC won't work. We sometimes get complaints from customers saying, you shipped us a BUC, it doesn't work, it won't output. And then when we go back and examine their equipment, we find that either they don't have 24 volts coming from their modulator, or they don't have 10 meg reference. Both of those are essential to make these smaller BUCs work. Let's take a closer look at this cross-guide coupler. You can see it's calibrated by output frequency. Take for example the 14.00 on the left, and beneath 39.88. What it does, it attenuates the signal by that amount, and so instead of getting the raw output from a BUC, it's knocked down by, in this particular case at 14 gig, 39.88. And when we look at the output on the power meter, we have to account for that. So let's get the show on the road and turn on the modem to start generating the output signal that we need to feed to the BUC. I'm connecting the power head to the cross-guide coupler. My first step is to set the power meter to recognize the same offset that we use on that cross-guide coupler. At 14.0, the offset is 39.88. That's set up. So now when we look at our output, this is the output minus 11.72 dBm, which is in the microwatt range. So this power meter is getting nothing at the moment. Let's go ahead and look at some of the parameters on the modem and see if we can gradually increase power and see the output on the power meter. First, let me check the frequency. 14.0 gig, and because this is an L-band modem, it's showing an output of 950 meg, which is correct. It's already set up in a CW or test mode, so I don't need to worry about modulation data, etc. I do need to go and look at power, and power minus 17 is a little high. I'm not going to start transmitting on that. I'm going to decrease the power. Typically what you do, you press the down button and it increases the value, and in increasing the value it means that you are attenuating the signal. Press enter. I'm going to go to the on off and press on. Looking at the power meter now, we've got an increase in signal. So I'm going to go back to the modem and I'm going to increase the power again. It's at minus 27. I'm sorry, I said increase the power again. In this particular case, I'm going to increase it. Last time I decreased it. So now I'm going to move it down to, it's minus 27, I'm going to move it to minus 20. So effectively I'm pressing my up arrow to minus 20, and then I press enter, and we see a jump on the power meter. We're going up to 1.84 watts. So I'm going to bring it up to about minus 17. I'm going to increase it, so I press the up arrow, and the up arrow reduces the attenuation, now to minus 17. And the power meter is showing 3.29, which is probably about where it should be at 14 gig. So I'm not going to push it any more beyond this. What I'm going to do now, I'm going to go to the other end of the frequency range, 14.5, and I'm going to run the same test. But first I'm going to take it off, transmit. Okay, it's knocked it back to ground zero. I'm going to go to frequency, and I'm going to increase the frequency. I want to take it up to 14.5. There it is, 14.5. But I've also got to change the frequency on the power meter to match that. Okay, everything is set up and calibrated. So now I can turn on the power on the modem, and we'll see what we get at the top end of the frequency range. And again, I'm starting at a lower value. And now turn on the signal. And we're just showing slightly less than 1 watt. Now I'm going to increase the power from minus 22 to minus 18. And that's brought the power up to 2.58 watts. So I think we can go a little more. Again, we assume this is going to be somewhere around 3 watt, 3.5 watt. It varies by frequency. Okay, we've got 16, neg 16. Now let's go and look at the output, 3.27. I'm going to go just another stop and see if we can get any higher. Set it to minus 15 now. There we are, we're at about 3.5 watts, 3.46 watts. I'm quite confident this is where it should be, and so I'm going to conclude the test now and declare that this particular BUC is in good working condition. And as we have quite a few more on the shelf, it's going to be a long day if we test them all.